Hi, folks. Today's episode, we're talking about keeping systems safe, a predictive talk across borders. I'm joined now with Yehu Ofer and Dr. Benad Goldwasser. Thank you guys so much for taking the time.
Our pleasure. Thank you.
I want to talk today a bit about, well, as the title of the episode suggests, which is about keeping systems safe, and not just safe, but healthy, and understanding some of the ways that impacts the predictive maintenance space. So, Yehu, I don't know if you want to go first, or Bernard, you want to go first, but I want to understand aspects of safety, and some of them are universal and some of them are highly tailored to specific industries.
Mhm.
So why don't we talk a bit about that for now, and
Okay.
then we'll dive a bit deeper into some of the history of what we're talking about.
Yeah, no problem. So I'll just say a word about safety. I'm coming from the aviation world and from the industry, and there are so many people, so many places that are either the cause for safety issues that are, if not being taken the corrective manners in time, so can decrease to a level of accident or to a level of event. It could be the factor of human, which is a human mistake can create a process that at the end will create to a failure and an accident, if a fatal event. It could be a failure of the machine, internally or outside, that is creating that, or degradation of a machine that hasn't been noticed, because at the end all the machines in the world are being taken care today in the way that either they are being taken care, either cars, for example, by kilometers. So after X kilometers, you're going into the garage and things are being taken care over there. Not necessarily the right things, okay, because every car rides in a different conditions, different environment, different roads, different driver. And the second, not less important here, is with that is hours of operation, that it connects to many other machines, that every X hours of operation you are creating maintenance procedures. And I think that Odysight could create and does create efficiency and safety within all of those environments.
Absolutely. I mean, that's one of the things that Odysight does. Is it does, I don't need to tell you guys, but it does predictive maintenance.
Mhm.
But before predictive maintenance, as you said, there was preventative maintenance. So, Bernard, why don't we talk a bit about that history and some of that change? Because what you folks are doing is using AI to kind of transform a traditional way of
Mhm.
preventative care. So, talk to me a bit about that.
Well, thank you. You know that I come from the field of medicine, and human beings are machines. We're biological machines. You can what Odyssey is treating is electromechanical machines, but humans are also machines. And in human health, we aspire to a preventive maintenance or preventive medicine. In other words, we try to tell people what they should eat, what they should not eat, how many hours they should sleep, how they should kind of medication to take for a cholesterol or a blood pressure problem. All that with the intention of preventing disease. In machines, we are way ahead, because we are not only into preventive, which was the thing of the past until about 15 years ago, whereas today we're talking about condition-based maintenance and predictive maintenance. And what is the difference? The difference is that if you implant sensors within machines, and these sensors can speak through the Internet of Things to the cloud and report to us what is the actual condition of the machine, then we don't need to do preventive, which has a lot of cost to it and a lot of work to it and a lot of spending of even endangerment, because when you open something unnecessarily, you may also cause damage. So by doing that, we are reporting the actual problem, or the condition-based maintenance, or the condition of the machine, not right now.
But if we follow that and extrapolate on the damage that is being created and any electromechanical damage, then we can predict based on extrapolation when that machine is going to fail and become a danger, and it will endanger, be it an airplane, be it a train, be it a truck, be it any type of machine.
It's so interesting when you mention that, because it's always been the discussion, right? It's like, are we animals or are we machines? And so I often find that whoever is having the conversation has a different insight.
I think animals are also machines. We just don't spend the money on doing preventive medicine for them. Okay, we just treat them when they're sick, or don't treat them at all. But I think that every biological a being is a machine. It's a biological machine.
Yeah, it's so interesting because people talk about whether it's one or the other, and here you are basically saying like, nope, we're all just machines, actually.
In a way.
Yeah, no, but so talk to me a bit about, because before Odysight was in the preventative, like, kind of in the aviation space, you were in the medical space. So talk to me a bit about that through line, about how they may have connected and what attracted you to that, because it's like an interesting journey.
Well, I was a chairman of a company that developed micro or very small video cameras for a medical application. And without planning anything of the sort, one day they were approached by NASA that was interested in tiny cameras for a project that they had in outer space of refueling of satellites in outer space. And they worked with a very large Japanese company that created these cameras for them. But they were able to create large cameras that allowed them to guide a fueling hose from a fueling tank into the satellite. But these cameras had to be very special because the conditions in outer space are minus 127 degrees centigrade. Radiation, cosmic radiation, which is like radiation inside a nuclear plant. There's no air because there's vacuum. And there's a lot of tilting associated with launching of satellites. So this company was able to create for them cameras that allowed them part of the job, but they needed them to create for them 3 millimeter cameras. And the Japanese company was not able to do that. Funny enough, they started looking through the internet for manufacturers of tiny cameras, video cameras, and they came across this company from Israel. And they asked the company whether their tiny cameras could work in those conditions in outer space. And it turned out that the company didn't know because they did it for medicine. 37 degrees centigrade, 1 atmospheric pressure, no radiation,
Yeah.
very easy. So they said, if you want to try our small cameras, try them. And NASA took the cameras, tried them, and lo and behold, it met all the conditions that NASA wanted.
Wow, that's
Now-
amazing, because a previous episode, another conversation here around some of the with your team members, I even made the comment of saying you guys could build stuff out of space with no.
Well, that's the way this company started. Because
Yeah.
when I heard that, I decided that we should think about using these type of cameras inside machines, because in predictive maintenance that we just spoke about before, or condition-based maintenance, they were using sensors of all types that are what we call electromechanical, measuring pressure, temperature, vibration, acceleration, but nobody was using cameras because cameras were considered too expensive and unable to withstand the conditions inside machines. So when I learned of these cameras, I said, well, maybe we can do something with that inside machines. And I connected with someone who was Jacob Bortman, Professor Bortman from the Negev University in Beersheba, and before that, he was the chief engineer of the Israeli Air Force. We talked about it, and he said, "Yes, I think that in aerospace this could work beautifully." And we started the company, and later Yehu joined us and took the lead on it. And today we're installed in different verticals and different type of machines. We do it in aviation, in UAVs, in helicopters. We do it in trains. We do it in trucks. We do it in all kinds of elevators, all kinds of verticals.
Yeah, it's amazing. What's such a great. I love hearing stories of companies that start off in one area, maybe doing one thing, and then by fate or chance, something it grows into something else. There are so many instances where that happens. Yehu, as mentioned, you kind of came in
Mhm.
now, and you're the CEO now. What are some of the, because the episode is focused on safety?
Mhm.
What are some of the biggest challenges that you saw or need to address um, when preparing for something like anything from space to elevation to aviation?
Okay. So first of all, you have to know or to have the expertise in order to allocate the root cause failure. Okay, in order to see a crack, to see corrosion, to be able to see a leak, so to detect the actual issue. That's the first one. With safety, it should be, and that's what we aim to be, in safety critical single point of failure inside the machines, because then in those areas I think that our contribution is valued the most, because and then you have to be able to detect the failure mode, and to be able to alert for that. So that's another. You have to stand for the conditions, for the characteristic, for the requirements, for the regulations that are within those industries, that are not easy to be environments that are easy to be installed in. And you have to be reliable enough in order that the detection will be there, because if you're not detecting something that has happened, so then maybe the safety issue evolves, and you haven't been able to detect it. And that's how we design, how we actually develop the company. So if you are, for example, if you are looking at something, so you're not looking, that's one of the advantages of those small sensors, because they are looking, and you're looking not just one time, you're looking continuously on something, and then anything that is happening, you can that you are being able to monitor. We have designed the size of the cracks that we are using in order to be able to detect those safety critical issues that are becoming. And the same goes for different environments, such as hot oil, okay, or places that are very critical. And the whole idea of the issue for me, it's not only the safety, it's because we are creating value through all the value chain of a machine. Okay, so I need to be, and there is another thing that is very connected, that maybe Benad will be able to refer to that. But that's that the safety is not only on the failure mode of the machine, because if you are being able to replace, because in this arena of maintenance, 99% of the actual checks that are being done by humans that are checking that the situation is correct. Okay. Now we bring two advantages to this area. So first of all, we are decreasing, I'm not saying eliminating, but decreasing the human error factor within that, because we are continuously checking something, and by that we are creating much more safety, and it's a dual safety, because it's safety at the procedure, and it's safety for the man that does not need to go inside into this very harsh environment. Okay, so that's one area of the safety that we are creating. And the other one, which is maybe not less important, is the ability to prevent something from happening. Because if, as we are doing, we are seeing the evolvement of a process, and we are being able to alert before it happens, so there lies, I'd say, the holy grail of preventing, or predicting something before it's happening, and prevent the fatal event. And that's our contribution to safety.
I would like to add to that actually, I was talking earlier at how we started from highly resilient, tiny video cameras. But actually, the big thing about the company or what we are doing is not the cameras themselves, but the algorithms and software that developed that allows us to detect any aberration, any deviation from normal, be it a crack, be it a leakage, be it a sweating membrane, be it a corrosion, be it icing, any type of electromechanical change from normal, we follow with the cameras and with the algorithms and software, we detect it, we follow it, and we then send it to the cloud where we can analyze it and then make the prediction. So that in the long term, actually, I think that both Yehu and I agree that this company is not going to be a hardware company. It's going to be a data company, a data analytics company, and a data company based on cloud and cloud computing, because that's our long-term vision for this company, okay? And not just the hardware.
So what happens, because you'll always have hardware, right? I mean, you'll become a software, oh, I don't know, maybe not. But
I'm not sure, okay, because if you look at the end, if there are the sensors and we have the algorithms, so I can be a software. The only thing that I care about is the data. If I can have the data that I'm analyzing and I am having the algorithm and the software, so I'm there. Okay, for now, there are no other sensors that can live within those environments. That's why we had to develop, and that's the origin. It's exactly connected to what you said before about the diverse of a company. This company started, as Benad said, as a small sensors company, small cameras for different applications, and it changed over to being a data analytics algorithm AI company because it had acquired data and it has the ability to be installed within those harsh environments. Okay, looking forward, wherever there is, if I have the data, so that's an advantage that we have in front of the market, of course. But looking forward, what's important and the core is the algorithmic and the software.
And although we were pioneers and first, and I'm not aware of anybody else yet with highly resilient cameras, as we described previously, we are very happy to add other sensors that others also have, and to create a whole picture for the client of all the aspects of his machine and all aspects of his machine failure. And that's why in the long run, we don't necessarily see the sensors as the important thing, but actually the algorithms, the software, and the data and data analytics. That's where we see the long-term ride of this company.
okay, wow, interesting. And what do you think about the um, entrance into other markets? Because we've spoken about aviation, we've spoken about space, we've spoken about other areas, vehicles that you guys focus on.
Okay.
How does that change your methods or
Uh,
tactics, whether it comes to regulation or industry? What is that looking like?
I think that happened in the last 3 years, that we have been able to understand and to change the company from I would say a proof of concept or demonstrating technology company to a product company. And today we can define that we have two products. One is for, let's say, for the aviation market, and the other one is for the industry. Okay, and I think that the core change here was the ability to use the same application, the same software, the same algorithms, and that's something that we came along the last 1 year and a half, and to implement that. And that's a deep technology because that's a core technology, that's a hybrid technology if you want, but we can leverage that into any industry because at the end the problems repeat. Okay, it's not it's the same. It may be a different metal in different materials, different infrastructure, but the actual use case are almost the same. And that's why first of all we are gathering data that is very relevant, and that's why we can be relevant for so many verticals. And here Benaz is all the time looks 3 steps ahead of me and looking into conquer the whole world. I'm saying let's take it not one by one, but let's take 2 at a time and not more than that, because otherwise we will run too fast. But the technology is the same, and that's a revolution. Okay, to be able to use the same software, the same algorithms, the same application into different verticals. That's a very interesting capability.
I think that what you just said at the end is very important, because it's the same algorithm and the same software that detect deviation. Because deviation, it doesn't, from a norm, it doesn't matter in what kind of machine it is. Okay, so what is going to be different from, let's say, an airplane than an elevator? An elevator is here on Earth. Okay, it's on the ground. It's 30 meters up or 100 meters up. It's not 40,000 feet up in the air. It's not where the temperature is minus 40 and there's winds and icing, etc. So the hardware is going to be different, right? The computers, the sensors, and that's why this price is going to be also different of the product. Whereas down here on Earth, if it's installed in an elevator or in a truck, you don't have those extreme conditions, but it's still the same software and the same algorithm telling you about the change, the electromechanical change that happened, and that doesn't matter which type of machine.
Well, it'll go up and down, but in different ways.
Yes.
Because it'll be on an elevator.
Yes.
Yeah. Talk to me a bit about the clients you have or customers you have within reason. I mean, I don't want you guys, if you can't share anything you can't share, I don't want to get you in trouble. But what's been the response with them and the adoption of what you folks offer?
Okay. I will.
I don't want to get anyone in trouble, by the way.
No
Get
worries.
him into trouble, not me.
I'm used to being
I'm
trouble.
trusting you not
No,
to say
I'm
anything.
used- It's fine. My responsibility. Let's start from aviation. Okay, I think that in aviation, first of all, we were endorsed by the both by the Israeli Air Force and by the Israeli MOD, and I think that the defense is a wonderful accelerator for our technology, because the need is there. Okay, and here we were implementing our platform and our solution into the SH-60, which is the marine version of the UH-60, which is a very common helicopter, and we are implemented into the as sole source contracted into the new Seahawks of the Israeli Air Force, and that's an ongoing process, an ongoing client, and we are there. We were contracted by one of the top 25 companies in defense companies in the world for a contract of hundreds of systems that will be implemented into 2 types of UAVs. One from design, that with this one we are flying since June 2023, and the other one is as a retrofit. And this area is booming in the world, and the amounts there are amazing. And it's not only that; it's that you cannot get platforms, and platforms are overused either by the situation or because you cannot buy today new ones, so or it's hard to get them. So a lot of retrofits are there, and then the need for our system like us is even bigger. The next one, we are very proud to say that we have been flying in out of Israel in Italy on Leonardo helicopter one Augusta Westland 139 under the Italian MOD and the Italian Air Force, which for us was a major breakthrough that we did. The next one that I want to share is the largest UAV in Israel, which is the Heron TP. And here I think it's this was published by the Israeli MOD, so I'm feeling free to share. But think about those kinds of UAVs who are flying to very long ranges within the challenges against Israel, and think about that here, that you can have in a machine that does not have no pilot on it, and you are being able to detect something that is starting to happen, and you can take decisions in the operation, and those are not only maintenance decisions, those are operational decisions, because if starts a leak and you need to decide if you can't bring back the UAV, and it takes you 7 hours to bring it back. So if you can leave it there because you know that the leak is very small, and it's very, in the prediction of this to become catastrophic is just in few hours, so you can operate it more time, and that's becoming an operational decision. We have been contracted by Safran to the French origin, huge concern to integrate our systems into development of a new jet engine, commercial one, into the guide vein of the in air inlet, and there we are implementing to see icing. And if I'm just for a second change over to the changeover, and we have been contracted, Benad said in the start about NASA, but NASA came back to us with a repeat order, which is something very unique with NASA that develop all the time something new. So they came back to us with a repeat order for a new type of sensors that we have been able to deliver last year. And changing over to the industry, we have been implementing our systems into heavy open mining trucks very successfully, looking into very, very harsh conditions over there. We have been implemented the system into elevators in Europe to a company that actually their responsibility is, you know, that when you're going into an elevator and you feel there are too many people there, not you of course because you look sharp, but someone there needs to go out because it's too much weight in the elevator. So this is those sensors are feeling the tension on the cables, okay, and they found out that they have really the need to see the cables or the stripes in order to see for a corrosion or for problem of stitches of breaking parts or for erosion of the component. And they contracted us through our European company for the first commercial order just few months like that. And I think that the Israeli Rail Authority that we have been integrated into the switches is another very very nice example within the I would say the industrial product. All use the same software, same algorithm, just sometimes a little different hardware. And here we are monitoring the switches that are safety critical system that are actually looking how the rail is moving from side to side and to know. And there we already proved that we can see problems that they have not been able to detect before. And we alerted to them, and when they came and saw it, so they saw that we already also did the prediction on it because we saw and alerted much before it was really happening.
We thank you.
Hmm.
No, it was great. Gives a great overview, and you really touched on the second half of our title today. So the first half was safety, and the second half was across borders.
Mm.
So borders aren't just industries, but they could be countries, they could be planets. There are many ways that you folks are crossing borders. So how does that change, in your mind, how to tackle some of these safety issues, whether it be cultural or economic or physical safety? I mean, how does it change? How do the demands on you change?
I think that Benad again, it's a question of Benad because the board actually asked us. We first of all there is I think that the company is a U.S. company. Okay, it's registered in the U.S. and I think that here in a very wise way we have been opening a company in the EU in order so to get into Europe and to be local in Europe. And we have been opening this company in January 9, 2025. And I think that it's starting to run very fast
Is that
forward.
in Italy or
Yes, it's in Italy.
Nice.
It's in Italy because we had there the project with
Right.
with the Leonardo helicopter, and a lot of our business is looking forward there. And Italy has a lot of influence in many areas. And it's very that's where we started, but we are looking at all of Europe from there, and of course in the US. And I really think that the company, any company, but the company needs to survive, and they need to adjust themselves to the market's requirements and to the geostrategic situations. And I think that here you see two areas that the world or the let's say the borders are changing dramatically. And I don't think that nobody saw it few years ago. One, okay, the AI is a wave that we are riding, and with that we can ride almost to any industry. And once you are using the same core technologies, so it's not easy, but it's easier to go from vertical to vertical. And the other one, not less important, is the defense wave, which I think is global, and I think that budgets are growing. and the need for machine and the need for safety and for operational availability and for something that is that prevents safety issues and create operational availability, and that's exactly what we answer.
Well, I want to touch on that as well because it's
Mhm.
come up a few times today. Is the connection, obviously, that you guys have with the defense industries, but also defense tech, and that as a sector, and
Mhm.
as we started the school as an accelerator for
Mhm.
change and innovation. Um, what part does that play in what you guys do, and how does that kind of impact the business that you do? Because a lot of it, when you hear defense, you hear the armies, right? Whether it's the IDF or whether it's NASA or
Mhm.
the American Army, but you hear all these stories of government and army agencies kind of being the birth hub of some of these innovations. Um, does that affect how you folks work in terms of public sector, private sector? Talk about that.
I think that then we started off, first of all, we went more to the defense, not because defense was sexy at the time, but because the regulatory hurdle was lower
Mm.
than the civilian. And that's why we initially targeted it. We little did we know when we started off 3 years ago with Yehu that in 1 year time there'll be a war between Russia and the Ukraine.
Yeah.
All of Europe will be changing. President Trump will be telling the Europeans, "Take care of yourselves. I'm not going to sponsor you anymore," and therefore the percentage of expense on defense in Europe went from less than 1% to closer to 5% in some countries. So we were very fortunate, actually, that we targeted ourselves so that in a way we are very sexy without intending that, okay? And so just like with the cameras that they were for medicine and they turned out for predictive maintenance of machines, machine health, same thing here. The wars that happened in Europe and of course also here in the Middle East caused the expense to be very large, and therefore we were spot on. Although our technology is not originally a defense technology, it can
Mm.
serve anything, and like we said, any type of airplane, any type of machine, not necessarily military.
Well, it
Okay,
speaks to the dual use nature of the
but
military.
but
Yeah.
we also hit on another very sensitive thing, which is AI, which is changing the world. So we are not only a defense company now, we're also an AI company. So in that sense, we're pretty fortunate.
Yeah, you're kind of at this perfect inflection
Mhm.
point of these two worlds colliding. Um, let's hope AI is not a bubble, and let's hope wars end. Um,
Let's hope.
I don't think AI is a bubble because if you look at the AI from a practical point of view, and I'm not talking about language,
Mm,
okay? Because language, you can ask yourself, is it a bubble or not? But I mean, look at even medicine. Today, AI is reading CT scans, pathology slides, hematology slides in a way that humans cannot do it. Okay,
yeah.
it's improving on our diagnostic because a machine, and that's what you said before, a machine doesn't make mistakes that humans do. If a human being is at night at the hospital and a resident, he can make 30% mistakes on reading a CT of the brain if a guy has a stroke or not. 30%, 30. A machine, less than 2%.
Mm.
Okay, so this is not going to go away. So AI at large is not going to go away. Maybe in some places it's being overused or over exploited, but AI is not going away. It's staying here, and in our field, this is going to make a huge change in the world.
You can see it already,
Yeah.
and also it's interesting you say that because when ChatGPT kind of became mainstream, a lot of writers like myself thought, "Oh my gosh, is it gonna destroy our careers? Because has it come for us in
Mhm.
terms of writing or storytelling or
Mhm.
messaging?" And it was a concern. But then you think that AI has been around for years because I've been using Grammarly, which is a plugin on Chrome that highlights, "Hey, I think you meant to write this
Mhm.
word," and I
Mhm.
think, and that what's that if not just an AI telling me that my
Yes.
spelling is wrong?
Yes. Yes.
Um, so the tech is there, but I guess the applications change, and it all becomes a bit less scary. So moving ahead, into the year and beyond, I suppose, how do you see? We've spoken about safety and we've spoken about borders and crossing them. How do you see collaboration happening, whether it's within Europe or Europe and America
Mm.
or Middle East, whatever, whether it's different industries? How do you see collaboration being fostered in the context of what you guys do, which is this AI defense
Mhm.
inflection?
Okay. You want to take?
Go ahead.
Okay. I would say like that. It's very, first of all, Odysight does not look to be prime. Okay. Odysight does not compete on something. It's collaborative by nature. Okay. Because we are an added capability into a machine or into a system. Okay. We are not staying there by our own. Okay. We will not be the plane. We will be the system that could help the plane to be more efficient, more safer, and less time taking on ground, less work. Okay. And that's why the nature of Odysight is collaboration. That's the first thing. The second is that I think that we can create a lot of value to many industries and to many producers and to many manufacturers. And here, the way that we look is to, from one hand, we are addressing the operators, such as, for example, Israeli Air Force, Italian Air Force. It could be Lufthansa, for example, or it could be any other operator of machines. Okay, in any field, by the way. And the other ones that we are addressing is the MROs. Okay, the MROs are the maintenance and repair offices. That they are the ones that are creating the maintenance procedures, and by nature they could implement more things inside. We are addressing, of course, the manufacturers, the OEMs, okay, because they could take our system and add it as a capability that will create for them extra capabilities because of the nature, both for the development of a new program, because we can cut down the time and the time and money to develop something new, because within the development you can see things that are happening and you need this data, and we are creating this data. But not less to that, to all what is connected to services, because once, if I look forward, and I will be very happy to hear Benad's view, but if Odyssey could become a legacy, or could become a kind of a procedure that is needed to be by Odyssey, let's say Odyssey standard, okay, or to become a kind of a standard in an industry. So there's a whole areas come behind it, because it contributes to the service, it contributes to the safety, it contributes to the efficiency, and it becomes something that you need to be. And that's actually what we aim as to be unique.
And I'd like to add to something that Yehu spoke about previously about the elevator company. In the elevator company, they already have sensors, and they're already working, and they are doing a fine job, and they have a lot of clients. It's a huge company. We didn't come to them and say, we are better, take your sensors out of the elevators, replace them with ours. We said, would you like to use ours as well? And lo and behold, they found out that we have added value. So it's not that it replaces somebody else's sensors. We can be an addition. So in some cases, we'll be the leaders and the prime, okay, because they have no sensors, and we're introducing them into this world of sensors and predictive maintenance. But in some cases, they already have their own sensors, and we're not saying them replace them with ours. Add ours. We'll give you another way of looking at the world. So
And are they
we're
open to
very
that?
happy. Of course, that's what happened with the elevator company. They
Right.
just added us. They didn't replace it. They just added us as another tool for the benefit of their clients. And their clients are very happy, both in the US and in Europe, with this.
So what happens to their existing or pre-existing tool?
They continue using it, but now they also have our way. It's just like you. If you close your eyes and try to reach the door behind me, you'll have a very difficult time just feeling your way around, or smelling or hearing your way around. You just open your eyes, and that's what we're doing. We're giving vision in addition to all the other senses that are already being used today.
Wow. That's great. I mean, I love that analogy as well about adding the eyes, because I would get to the door, but not without pulling over a few of these microphones and lights along the way. Folks, we're approaching the end of the time that we have. It's flown by. I can't believe it's already happened so quickly. I just wanted to leave you with some, or give you the opportunity to leave with some final thoughts or comments about the state of the industry or the state of you guys, or some maybe the exciting things that you have lined up that you can share with us today.
Benad. No, Benad, take it.
And I'll pick whoever looks less comfortable. So
No, I think that like every other trip or every other, you start it with one step and then you add more and more. And I think that we're on the right path, on the right way. I think that we have a right model. It takes time, especially when you're not only software, but you're hardware and software. And I think that we are now finally, we can say that we've brought our technology to the stage where we are beginning to run on the runway. And when we'll start flying in the air, I think it's going to be very soon.
ready for takeoff.
Ready to right now. Right.
Yehu, final words?
I think that I've been asked a few times what are the limits, okay, and it's connected to the borders. And I actually I don't think that Odysight technology has limits. I think it could be huge, okay, that's and very fast. I think it's at the end it's based on teamwork, okay. There is nobody alone here. There is a full team that is supporting and creating that. Not a lot of people, by the way. And I think that it's also very, for me, it's at least it's a very say different thing from what I did in the past, in the way that a very to see that a very small company can do something that is new in the world and add to this to this world, bring in, as I said, more safety, less people hurt, less people are getting injured, and more efficiency, and actually that's
And cost saving.
and cost saving, and for me, coming from other places in my career, it's very nice to be in a place that is actually creating good, which is wonderful.
That's all we can ever hope for. Do good and create good.
Yeah.
Guys, thank you so much for your time today. It was super inspiring.
Thank you.
Thank you.
Thank
Thank
you.
you very much.